Okay, the last part of the course today is how we add some user interactions to any game objects by using scripting. Yeah, how we create a script in Unity. So there are some differences between scripting or coding in Visual C# and scripting in Unity. Yeah, Unity treats scripts as components, thus they are modular. Yeah, what it means. Um, for a modular script, that means that we can write a script and then we can use it multiple times for any different game object. Yeah. So here in Unity, a script actually defines the behavior of a game object. Yeah. It is not the game object itself. Usually, if you go, code in Visual C#, yeah, you will script or create a new class for every objects in your form. Yeah, so a button is an object. It requires a new script, and then you create a player script. Yeah, you create enemy script, you create let's say item script, and so on. But here in the Unity, we will actually create a script for the behavior of any game objects. Yeah, so for example, a car can move, a ball can also move, an enemy also can move as well. Here we have a similar behavior. There is move, so those three game objects can share one script. We call it move later. Yeah, for this reason, Unity scripts are derived from a mono behavior class. This is the superclass for any scripts created in Unity. Yeah, Unity allows us to create scripts in C# or JavaScript, but for simplicity, we will just use C#. Yeah, you have already used C# for 2 semesters already, so I think learning script in Unity is only familiarizing ourselves with the classes used in Unity. So let's say that our car will move forward to the z-axis each frame. Yeah. Let's create a new script called a car movement. Yeah. Before that, make sure that you have scripts folder. Yeah. This is a asset management. If not, then please create it first. Right click here on the empty space on your project window inside assets. Then select create and then select folder. Name it scripts. Yeah, and then again open your folder, your scripts folder, right click again, but this time create and C# script. Yeah, and then this is important, you must give name to your script now. Let's say car movement. Yeah, please don't name your script later. Yeah, so for example, you created a script, create C# script, and then you leave it like this. Yeah, accidentally click somewhere else. Yeah, this means that your script will be called a new behavior script, and the created class is also a new behavior script. Remember that in C#, the class name must match exactly the same with the file name. Yeah, so if you rename this script to something else, yeah, then it will no longer match. Yeah, you have the file name is car, but the class name is still new behavior script. Yeah, this will lead to a C# compile error because the file name does not match with the class name. Yeah, so please avoid that. Yeah, if you create a script, then give it name immediately. Yeah, create C# script, name it immediately car, so that Unity can actually generate the correct class definition for you. Yeah, I will delete my car script. Yeah, so I will have only the car movement script. Yeah, and then simply double click it. Yeah, it will open a Visual Studio. I use Visual Studio 2017 here, but if you want, you can also use the latest one, yeah, Visual Studio 2019. Yeah, I will pause my video for a moment, and then I will resume. Oh, it is actually faster than I thought. Yeah. Usually, if you have a faster computer, then it will open immediately. Yeah, but if not, then just be patient. Yeah, just wait until Visual Studio loads your project and opens the correct script here. Yeah, if you open the car movement script, then wait until Visual Studio load your project, the solution for your Unity, and then your script, the car movement script, will be shown over here. Okay, so I will pause this video for a moment. Yeah. Okay, so oops, sorry. Yeah. Okay, so my Visual Studio has fully loaded. Yeah, with the car movement.cs here. This is my car movement script loaded in Visual Studio. Yeah, but if by any means you don't have any Visual Studio, or you load something else and you want to use a Visual Studio, yeah, then you can change the editor, script editor for Unity. Yeah, just click the menu Edit, and then select the Preferences here. Then look at the External Tools tab and select the External Script Editor here. Yeah, when installed correctly, it will already detect my Visual Studio here, and I also have a Visual Studio Code. Yeah, you can change your preference here. Yeah, I will leave the Visual Studio 2017 here. Yeah, if you install a new Visual Studio, when you install also the Unity editor, yeah, it will actually install a Unity and Visual Studio integration tool. Yeah, so if you can see at my Visual Studio here, I no longer have a play or run, but I have attached to Unity instead. Yeah, this means I can use the debugging feature of Visual Studio when debugging my game. Yeah, but for now, let's just ignore this. Yeah, we will try to debug later when necessary, because our script is usually very simple. Yeah, I hope you don't get any errors when creating the scripts in PBM. Okay, so for now, by default, the Unity will generate two methods already in the script. Yeah, if you see here, I have void start and void update. Yeah, as you can see from the comments here, start is called before the first frame update. Yeah, this means that start can be used as a initialization. Yeah, compared to the OOP. Yeah, in OOP, you must create a constructor to initialize your class. Yeah, here in Unity, you must not use the constructor. Yeah, please use start instead. Yeah, and Unity also forbids you to create a new object based on mono behavior. Yeah, so you cannot create something like this. Car movement X equals to new car movement. Yeah, please don't do this. Yeah, new mono behavior class should not be created or instantiated by using a new keyword. Yeah, never do that in Unity. Yeah, so you start to initialize something. Yeah, for example, like player's health or the player's initial velocity and so on. Yeah, the next method is called update. Here, the comment says update is called once per frame. Yeah, so update is the heart of any games in Unity. Yeah, because all of the game logic usually resides in the update method. Yeah, if you want to do something that must happen for some time, yeah, use update. Yeah, you can also regard this like in Visual C Sharp. Let's say it is more likely like the a timer tick. Yeah, in Visual C Sharp, a timer ticks every interval. Yeah, here Unity have a update. Update will be called will be ticked uh, for for every frame. Yeah. Once per frame, how long it is? It is very dependent. Yeah. Uh, for update, it is actually depends on the frame rate. Yeah. If you play any games that you will know the usually our frame rate is maybe 60. Yeah, we usually target for 60 FPS. Yeah, but for some games, you may have a higher FPS, yeah, 120 or 144, and so on. Yeah, so update is highly volatile. Depends on the current frame per second or frame rate. Yeah, that means if my frame rate now is 60 FPS, then update will be called 60 times per second. Yeah, but if my frame rate suddenly drops to 30 FPS, say, then update will be called 30 times per second. Yeah, so usually update is not suitable for any physics simulation. Yeah, it is not recommended to do some physics calculation in update. Yeah, but we will talk about it later. Yeah, in the next courses. Yeah, for now we will just use simply the update method. Yeah, so let's say that we want to move our car to move in the positive z-axis. Yeah, we can invoke the transform.translate method, something like this. Yeah, at this frame we will move the car by 1 unit to the positive x-axis. Yeah, if you notice here, Unity uses a camel case for fields. Yeah, they call it fields, but actually it is properties in uh, your OOP course. Yeah, so for factor 3.forward, the forward is actually a property. Yeah, not fields, but Unity simplifies them. Properties is also called fields here. Okay, let's type it here. Transform dot translate. Let's give it an argument factor 3 dot forward. Yeah, factor 3 dot forward is a shorthand for writing factor 3, 0, 0, and 1. Yeah, which means the z positive axis. Translate method will move the transform in the direction of this, yeah, to the factor 3 dot forward. Transform is actually the refers to the transform of the game object. Yeah, so transform will call this component actually. Okay, our script is roughly complete. Yeah, you can save it now. Yeah, you can save it, but please don't run it. Yeah, we can only run any script in Unity itself, not in Visual Studio. Yeah, so go back to your Unity editor. Yeah, and usually your Unity will freeze for a moment because it must compile with the it must compile the script first. Yeah. Wait. Okay. I have an error. Let me correct this error first. Then we will continue later. Okay. Please pardon my errors here because I have some ransomware protection which prevent the Visual Studio to actually write or compiles my script. Yeah, but it is now um, allowing my Visual Studio. Yeah, so hopefully everything will be fine from now on. Yeah, let's continue. If you immediately play your game right now, yeah, actually the script will not be executed. Yeah, why? In Unity, if you have any script that is derived from a monobehavior class, then you must attach it first to the respective game object, yeah, before it can be run. So what it means, here we must attach this car movement script to the car game object. Yeah, how to do that? Simply drag this script from the project window and then drop it right at the car game object. Yeah, if you do it correctly, then check your car at the inspector. You will have a car movement script component here. Yeah, you can also add your script via the add component button. Yeah, add component, and then make sure the search field is clear. Yeah, and then you can click on scripts, and every script you have created will be shown over here. Yeah, but usually I like to drag and drop instead of using the add component button. Yeah, make sure your car movement script is already attached to the car, and then you can run it. Play. Okay, my car now moves to the Z positive direction. Yeah, although maybe the speed is too fast for my liking. Yeah, but at least I have already made that my car now moves. Yeah, instead of just sitting there like a park car. Yeah. Okay, so there is the basic of creating a script and then attaching it to any game object, yeah, in order for that script to be executed. Yeah, so please remember, don't run it from the Visual Studio. Yeah, you must attach the monobehavior script to a game object. Okay, playtest, the shortcut is Control P, not F5. Yeah, maybe from the Visual Studio times, yeah, from the first part of the PBM course, yeah, you usually hit F5 to test your code. Yeah, now it's Control and P, yeah, no longer F5. Okay, now for exercise, try to modify your car rotation and or scale as well. Yeah, just do it in the update method. Rotation can be done invoking transform.rotate. Scale can be changed in transform.local scale field. Yeah. So for example, let's rotate the card transform.rotate. To which axis we want to rotate the car. Let's say factor 3 dot up. Yeah, that means I want to rotate my car to the y axis. Yeah, let's save this and see what happens. Okay, play. Okay, now my car is nowhere to be seen. Oh, okay, here. And as it rotates, it also moves to the z direction. Yeah, let's say that I want to increase the rotation speed. I can just multiply this factor 3 to up by any value. Yeah, let's say 30. Oh no, 30 is too big. I think 10. So now my car will rotate faster, hopefully. Yeah, let's play it. Okay, now it moves in a circle because I translate my car to the z direction, but at the same time I also rotate my car to the y axis. Yeah, so it moves in a circle like this. To modify the scale, we can change it in the transform.local scale. Transform.local scale, which is a factor 3. Yeah, let's say equals to or wait, let me think. Yeah, or times equal with 2. Yeah, this means every frame the local scale will be multiplied by 2. Yeah, but I think this will make my car be bigger very quickly because it is done very frame in every frame. Yeah. Okay. I must use a very small number. Let's say 0.02. And Unity works in float. So for now, yeah, from now, if you want to write down a decimal number, please end it with f. Yeah, this means that our number is no longer a double, the default one, but it is a float. Yeah, because Unity works in float. Okay, let's see what happens if I multiply my local scale by 0.02 every second. Oh, sorry, every frame. Yeah, but if you multiply the local scale to something like this, then it means that it will be smaller. Yeah, it will shrink very quickly. Yeah. Okay, so it's not plus multiplied by 0.02, but let's say that I want to add it with another factor 3, but I will use a very small increment here, 0.05 f, 0.05 f, and also 0.05 f. Yeah, this means the local scale of my car will be added by the x with 0.05, y with 0.05, and also the z value with 0 and 0.5 each frame. Yeah, let's see what happens. Okay, now my car is still grows very quickly. Yeah, but at least you get the point. Yeah, if you want to scale your game object, then you may use transform.local scale. Yeah, so by far we have already created some interesting effects to a game object. Yeah, but what if we want to actually control the game object itself? Yeah, so we need to detect user input now. Okay, Unity provides a static class input to detect the user input. Yeah, and actually from 2019 and onwards, there is a new API developed to detect the input. Yeah, in a more sophisticated way. Yeah, but we will just use the classic system for now. Okay, for multi-platform development, yeah, in because Unity supports multi-platform development. If you want to create a game that works on as many platform as possible, yeah, for example, like PC and then Sony PlayStation 4, Nintendo Switch, or Xbox One, then it is highly recommended to use virtual buttons instead. Yeah, instead of hard-coded keys. Yeah, so for example, for now you may be tempted to detect user movement by detecting WASD for keyboard. Yeah, but that means if you export your game to PS5, oh, for now PS4, yeah, PS5 is still in development, yeah, to PS4 or Xbox One or Nintendo Switch, then your game object will not be able to move because they don't have WASD. Yeah. Instead, they have joysticks. So starting from now, we will detect virtual buttons instead of hard-coded keys. Yeah. For example, to detect a movement, we will use a horizontal and vertical axis. Yeah, instead of WASD. The mappings of all virtual buttons in Unity can be changed in what we call Input Manager. Yeah, let's take a look at the Input Manager. From your Unity editor, just select Edit, then Project Settings. You will have many project settings here. Yeah, please select the Input Manager, then expand the axis here. Yeah, by default, Unity gives us 18 virtual buttons. Yeah, I have horizontal here, vertical, fire 1, fire 2, fire 3, jump, mouse X, mouse Y, mouse scroll wheel, and then it is repeated. Yeah, horizontal, vertical, fire 1, 2, 3, jump, 2 submit buttons, and 1 cancel. Yeah, this is the default virtual buttons given by Unity in a fresh project. Yeah. You may want to expand one virtual buttons. Yeah, for example, I will expand horizontal here. I can give the name horizontal. I can give a description here. Yeah. For example, if you want to create a settings in your game, yeah, and then you want to explain to your player, well, what is this button actually does, then you can give a description there. Yeah, and then we have negative and positive button. Yeah, negative button simply says that if left is pressed, then it will be regarded as negative. Yeah. Otherwise, if we have positive button right here, yeah, if the player presses the right key, then it will be regarded as positive. Yeah, having the positive value. Yeah, for other settings, you can refer to the input manager in the Unity docs. Yeah, the URL is here in the slide. Yeah, later you can visit the documentation. Okay, for now, we will leave it as it is. Yeah, remember the horizontal and vertical virtual buttons here. Yeah, we will try to detect the movement. Yeah, when the user presses W, A, S, or D, then we will move the car accordingly. Yeah, to detect movement, then by default, Unity already provides us two axes, the horizontal and vertical axis. Yeah, Unity already provides the WASD layout for us. Yeah, so WS is is used for horizontal axis, then A and D is used for vertical axis. Yeah. If you don't like the WASD, you can use the directional arrows instead. Yeah, up and down for horizontal, and left and right for vertical. Okay, let's change our update method in the car movement script to something like this. Yeah, this is to detect the movement in horizontal and vertical axis. First, I will remove all of this. Yeah, and then I want to create two variables. The first one is horizontal equals to input dot get axis. The axis name is horizontal. Yeah, please be careful here. The axis name is case sensitive. Yeah, so you must use the uppercase H. Yeah, in the same way for the vertical movement, I will create a vertical variable first. Yeah, then I will give it the value of input dot get axis. Oops, get axis in a vertical axis. Yeah, use the uppercase V here. Input dot get axis, it will return the value of the virtual axis. Yeah, identified by horizontal or vertical. Yeah, it will return 1 if the positive button is pressed. So if a player presses D on his keyboard, then input.getAxis horizontal will return 1. Yeah, and then getAxis will also return -1 if the negative button is pressed. Yeah, so for horizontal input.getAxis horizontal, it will return -1 if A is pressed. Yeah, otherwise 0 if nothing is pressed. Yeah, so we can actually use these values, the horizontal and vertical, to move the car. Using transform.translate, I will create a new vector tree here. Horizontal is bound to the x-axis. Yeah, the y-axis is 0. And then for the vertical, I will bind it to the z-axis. Yeah, that's why when creating the car, I told you to create it so that the front part of the car points toward the z positive axis. Yeah, that is why. So now save your script, go back to Unity and run it. Yeah, now our car stands still, but if I press W, it will go forward. If I press Z, it will go backwards. I press D, it will go right, and press A, it will go left. Yeah, so we have already detected the user input for movement here. Yeah, this is the explanation for input get axis. You can refer it to it later if you forget what is the meaning of input dot get axis. Yeah. Be careful again with the axis name. It is case sensitive, so horizontal you must write it down with the capital H. Yeah, for vertical you must write it with a capital V. Okay, sometimes when you create a script or when you edit your script, yeah, it does not happen here right now, but sometimes when you edit your script, then you won't get the autocomplete like this. Yeah, input dot get something Yeah, you don't get the autocomplete tooltip, and then if you notice at your declaration of your class, then the mono behavior is not colored cyan like this. Yeah, maybe it will be colored black or white depending on your theme. Yeah, basically the color of the mono behavior class is not the same with the color of my class. Yeah, if that happens, then there is actually a broken link between the Unity and Visual Studio project. Yeah, this happens sometimes. Yeah, hopefully not frequently when you learn Unity later. Yeah, if this happens, yeah, just close your Visual Studio, and then from the Unity editor, just click the Assets menu and then open C# project. Yeah, by using this menu, Unity will regenerate the files required to be able to create the Visual Studio solutions. Yeah, hopefully after that, the situation will be remedied by itself. Yeah, you will have the mono behavior color is the same with your class name, and you will gain again the ability to autocomplete. Yeah. What about the other input? Yeah, which is not the movement. Yeah, it's not the WASD. Yeah. So for example, let's say the car jumps when we press the jump button. By default, jump button is mapped to the space. Yeah. Let's try that. Modify your update method to something like this. So add a third float variable jump equals to input.get button jump. Yeah, if you see here in the tooltip, I will close my uh, my code first here. Yeah, if you see here, the input.get button returns true while the visual button is held down. Yeah, so it returns true or false. Here I will just simply make it so that if the jump button is being held, then I will give 1 to my jump variable. If not, then 0. Yeah, this is the conditional operator in C#. It is actually the same with if and else. Yeah, something like this. I will rewrite this expression in if then else. Yeah. If input.getButton jump, then x equals to 1, else x equals to 0. Yeah, these expressions is actually the same with this one. Yeah, so the conditional operator here checks whether or not the condition is fulfilled. If yes, then it will return 1. Yeah, it will return something between the question mark and colon here, and it will assign it to the variable here. Yeah, so that means if input.getButton jump is true, then 1 is assigned to the variable jump. But else, if input get button returns false, then 0 will be assigned instead. Yeah, so this is the alternative to writing if and else. Yeah, and now I will just add this jump variable to the y-axis. Okay, save it, and then see what happens when you press the space button. Yeah, actually this is not jumping. Yeah, the car will will move forward. And if you held down space, then it will move for eternity, yeah, until you no longer press the jump button or the space key. Yeah, so we have another method here, input.getButton. Yeah, it detects button presses, it returns true while a button is being pressed. Yeah, so you can see here, as long as I presses the space, then my car will move upward. Yeah. In the meantime, we also have the input.getButton down. Yeah, it can also detect the button press, but it returns true only at the first frame where the button is being pressed. Yeah, otherwise it will return false. So this is the difference between getButton and getButton down. If I change my float jump into input.getButton down, yeah, and then I press space here, you can see my car only moves once. Yeah, I must repeatedly press the space button in order to my car actually jumps. Yeah, so there is a difference between input.getButton and input.getButton down. Okay, it is not really a jump motion. Yeah, we haven't learned physics in Unity. We will learn in the next courses. Okay, so that's all for today's course. Yeah, we have learned a lot using Unity. Yeah, we have learned how to install Unity, and then we have learned how to create objects and manipulate them using tools. We have already learned how to navigate in the scene, and lastly, we have already added a very simple script. Yeah, uh, in order to create some effects. Yeah, for example, here we have created how our car can move forward to the Z axis. Yeah, and we have also learned how to detect user inputs. Yeah. So I guess that's all for today. Yeah, if you have any questions, you can write it down in the comments, or you can actually talk to me in the Google Classroom, or I will provide you a link to the Google Hangouts group chat. Yeah, I will see you soon next week in the next topic. Yeah, we will try to actually implement physics in the Unity. Yeah, until then, see you later.